Good morning, students. Welcome to the software engineering course under Markout. This course will help you understand key concepts and clear your doubts regarding this subject. Stay engaged as we will be covering essential topics step by step. We will also bring another part soon to deepen your understanding. Let's begin.
It's a pleasure to be here today to talk about something that plays a crucial role in modern software development, the Rapid Application Development (RAD) model. If you are aspiring software engineers or developers, understanding RAD will help you build applications faster and more efficiently, keeping up with the industry's fast-paced demands. What is RAD? As the name suggests, Rapid Application Development (RAD) is a software development methodology that focuses on quick prototyping and iterative feedback rather than spending months planning before writing any code. Imagine you're working on a project where requirements are constantly changing. Maybe you're developing a mobile app, and user preferences keep evolving. Traditional models, like the waterfall model, require completing one phase before moving to the next, making changes difficult. But RAD is flexible. It allows developers to build prototypes, test quickly, get user feedback, and make changes on the go, just like how modern software companies operate. Phases of RAD model. The RAD model is divided into 4 key phases. Requirements planning phase. This is where everything starts. Instead of writing long documentation, stakeholders, clients, developers, and business experts have a structured discussion about business needs. The goal is to quickly understand the problem and outline basic requirements. User description phase. Here, automated tools like case diagrams, wireframes, and modeling techniques capture information from users. It ensures that developers understand exactly what users need before jumping into coding. Construction phase. This is the most exciting part. Developers start building the application using productivity tools like code generators and screen builders. The development happens in a time-boxed manner, meaning and quote, do until done and quote, you keep refining the product until it meets expectations. Cutover phase. This is the final step. Installing the system, conducting user acceptance testing, UAT, and providing training so that the end users can work efficiently with the software. Why should you use RAD? Faster development. You don't wait for months to see the first working version. Instead, you get quick prototypes, better user satisfaction. Users give feedback in real time, ensuring that the end product meets their needs. More flexibility. Since requirements change frequently, RAD helps adapt quickly without delaying the project. Where is RAD used? Web and mobile app development. Apps like Instagram or Zomato constantly evolve based on user feedback. Enterprise software. Companies use RAD to build business applications that meet their changing needs. Startups and agile teams. Fast-moving companies rely on RAD for quick iterations. Conclusion. In today's world, where speed and flexibility are key in software development, RAD is a powerful approach. It allows developers to work smarter, not harder, ensuring that applications meet user needs efficiently. RAD provides a solution by focusing on speed, flexibility, and continuous customer involvement. Let's break down some of the key benefits of RAD. Reduced cycle time and improved productivity. RAD allows developers to build applications faster by focusing on prototyping and user feedback rather than long documentation cycles. Fewer people can achieve more. reducing costs while improving productivity. Time box approach. Have you ever heard of projects dragging on for months or years? RAD uses a time boxing approach, meaning development is done within fixed time frames. This reduces the risk of delays and helps teams manage budgets effectively. Customer involvement throughout the cycle. One major flaw in traditional development is miscommunication between developers and customers. RAD keeps customers engaged throughout the process, ensuring the final product meets their expectations and business needs. Focus on code, not just documentation. In RAD, the emphasis shifts from lengthy documentation to actual development. RIT follows the WYSIWYG principle, and QUAT, what you see is what you get, and QUAT, meaning users can interact with a working prototype instead of just reading about it. Use of modeling concepts. Instead of writing everything from scratch, RAD relies on visual modeling tools to capture business, data, and process information efficiently. This makes it easier to design and modify applications without unnecessary complexity. Conclusion. In today's competitive world, companies and startups need to build software quickly while staying flexible to customer needs. RAD is a game changer that helps developers work faster, reduce costs, and create better products through continuous feedback. The weaknesses of the Rapid Application Development (RAD) model. While RAD is known for its speed and flexibility, like any methodology, it comes with its own set of challenges and limitations. 1. The need for quick responses. One of the core principles of RAD is fast development and continuous feedback. However, this requires teams to give quick responses to user inputs, which can sometimes lead to rushed decisions. If teams don't respond efficiently, the entire process can slow down or result in poor design choices. 2. Risk of never achieving closure. RAD encourages continuous iteration and frequent modifications. But this also means that projects can become stuck in an endless cycle of changes, with no clear endpoint. Developers and stakeholders must set clear milestones to avoid unnecessary delays and ensure the product is completed on time. 3. Hard to use. With legacy systems, RAD works best with modern, flexible technologies, but it struggles when integrating with legacy systems. Older systems often have rigid architectures, making it difficult to implement rapid changes or modular updates. This limits RAD's effectiveness in industries where older technologies are still in use, such as banking or government sectors. 4. Requires modular system architecture. For RAD to be successful, the system being developed must be modular, meaning it should be designed in independent, interchangeable components. If a project has a tightly integrated structure, applying RAD can be challenging and may lead to code instability or maintenance issues. 5. Requires high commitment from developers and customers. RAD involves frequent collaboration between developers and customers in a short time frame. This means that both parties must be highly engaged and responsive. If developers or customers fail to commit to fast-paced decision-making and feedback cycles, the project can lose direction and miss deadlines. Conclusion. While RAD offers incredible benefits in terms of speed, flexibility, and user involvement, it is not a one-size-fits-all solution. It requires quick responses, modularity, and a strong commitment from both developers and stakeholders. To overcome these challenges, teams must carefully plan, set clear goals, and ensure they are using the right technology. When to use RAD. 1. Reasonably well-known requirements. 2. User involved throughout the life cycle. 3. Project can be time-boxed. 4. Functionality delivered in increments. 5. High performance not required. 6. Low technical risks. 7. System can be modularized. An important aspect of the structured evolutionary prototyping model, when to use it. While this model offers flexibility and iterative development, it is not always the right choice for every project. Understanding when to apply it effectively can lead to better software development outcomes. Handling unstable or unclear requirements. One of the best use cases for evolutionary prototyping is when requirements are unstable or need clarification. In many projects, especially at the beginning, stakeholders may struggle to define exact needs. Prototyping allows developers to build a preliminary version and refine requirements through user feedback, complementing the waterfall model. This model is particularly useful during the requirements clarification stage of a waterfall model. Instead of moving forward with incomplete or vague requirements, evolutionary prototyping can help validate expectations before committing to full-scale development. Developing user interfaces. Another ideal scenario is when the project involves developing user interfaces. UI design is highly interactive and benefits from continuous user feedback. Prototyping ensures that usability, aesthetics, and functionality are refined before final implementation. Short-lived demonstrations. Prototyping is also effective for short-lived demonstrations. If you need to showcase a concept, test a new idea, or present a working model for approval, a prototype provides a functional representation without the need for full-scale development. New and original development. When working on new, original development, evolutionary prototyping helps navigate uncertainties and allows teams to explore different possibilities before finalizing the design and architecture. Object-oriented analysis and design. Finally, this model is useful for the analysis and design portions of object-oriented development. Since object-oriented programming relies on modular and iterative design, prototyping can help refine class structures, relationships, and interactions before committing to the full system. Conclusion. In summary, the structured evolutionary prototyping model is highly effective when dealing with unclear requirements, developing user interfaces, presenting short-term demonstrations, or working on innovative projects. It also serves as a valuable tool during the early stages of structured development. Methodologies like waterfall and object-oriented programming. By strategically applying this model where it fits best, teams can create better software with improved user satisfaction.